Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Jadi hari ini kita akan membincangkan soalan pre-LEPAK chapter 2. Okay, jadi before kita membincangkan soalan ini, jadi mari kita recap sedikit formula-formula yang digunakan di subtopik 2.3 projectile motion. Okay. So 2.3 projectile motion, kita tengok balik apa formula yang kita gunalah. Okay. Right, so daripada 2.2, kamu dah belajar linear motion equation, iaitu kita tahu formula dia adalah V is equals to U plus AT, di mana V adalah final velocity, U adalah initial velocity dan A adalah acceleration, T adalah time. And then kita ada juga V square equals to U square plus 2AS. Okay, S ni adalah displacement dan juga kita ada S is equals to UT plus 1/2 AT square. Okay, so I am going to convert all of these equations into X and Y component. Okay, right, as we all know, if you dekat X component, the acceleration would be 0 lah. Okay, so kita tiada acceleration di X component. Okay, but di Y component, okay, we have the acceleration, iaitu acceleration due to gravity. So disebabkan gravity sentiasa ke bawah, so it will be negative downwards and G, and we know that the value of G is negative 9.81 ms negative 2. Okay, so this one should be 2, sorry. Okay, so I'm going to write the formula down. Okay, so this one we have Vx is equals to Ux, okay, plus Axt. But since Ax is 0, so you ada Vx equals to Ux saja. Okay, same with this equation 2. So we have Vx square equals to Ux square. Again, dia ada belakang 2x ni juga, tapi this one will be 0 lah, okay, because our Ax is 0. Okay, so this one macam ni, and then if we square it at both sides, you will be left with this Vx equals to Ux lah, okay. And then we have Sx is equals to Uxt. Again, I don't have this one because the value of Ax is 0 lah, okay. So these are the equations for the X component. So I'm going to do for the Y component, okay. Okay, so this one I have Vy, okay, equals to Uy. Now our A is negative G, so I'm going to write down negative GT, okay. So I didn't denote any Y or X at the T component because T is a scalar lah. So scalar quantity dia tiada X atau Y lah, okay. So and then we continue with this one. Vy square is equals to Uy square minus 2, again misconvertkan this one, 2gs, okay, 2gsy, okay. So since s is a vector, so we have to clarify it as to be x or y component, okay. And then we continue with this one, sy is equals to uyt. Again, I will replace this one with negative g, negative 1/2 gt square, okay. So these are the formula that we are going to use in these questions, okay, especially in projectile motion questions lah. Okay, so let's try to do question number 1 together. Okay, let's read the question together. So an Alaskan rescue plane drops a package of emergency rations to stranded hikers as shown in figure below. The plane is travelling horizontally at 40 ms negative 1 at a height of 100 meter above the ground. Okay, so we have a rescue plane and then we have the stranded hikers, okay. So what happened, this rescue plane will drop a package lah, package untuk emergency. So what happened, the package will fall down from here until here lah, nak bagi dekat hikers yang terkandas ni, okay. And then dia cakap this plane is 100 meter above the ground, okay, above the ground. And then the plane is travelling horizontally. Horizontally maksudnya bergerak di macam ni lah, horizontally, okay. So make sense lah, horizontally plane bergerak macam ni kan. Jarang kita ada plane yang bergerak macam ni, okay. And then kelajuan dia adalah 40 ms negative 1, okay. Right. So, kita tengok dulu soalan ni nak apa. Okay, soalan ni nak how long does it take for the package to drop? So, how long does it take ni maksudnya dia nak time lah. So, we know that A, dia nak time. Time from where to where? Dia nak time from here until here. Berapa masa yang dia ambil Okay. And then for B, dia nak where does the package strike the ground relative to the point at which it was released. Okay. So, dia nak kat mana? Okay. Where does ni selalunya distance lah kan. Displacement. Di mana package tu strike the ground. So, the package will drop here. And then relative to maksudnya adalah from the point at which it was released. So, ini tempat dia release kan. So, maksudnya daripada sini sampai ke sinilah. Okay, so we know that this is a distance. But a distance in the x component lah. As you can see, it's a displacement. But in the x component. So, we don't denote this as sx. Okay. So, we know that question number B wants sx tu berapa. Okay. How about C? C, what is the velocity of the package just before it hits the ground? Okay. So, the velocity just before it hits the ground would be here lah. Okay. So, this one is our V. Okay. But in order to find our V, we need to find the value of our Vx first. Berapa. And then our Vy berapa lah. Okay. So, the keyword is C. Dia nak V lah. Okay. So, tapi nak cari V, kena cari dulu our Vx and then our Vy. Okay. And then for D, dia minta the angle of the impact. So, angle of the impact. So, dia sengitkan benda ni. Jadi, dia ada angle. Okay. So, dia nak angle lah. Okay. So, let's try to do A first. Okay. But before we do the A first, let's identify apa yang kita ada. Okay. So, this one we have 40 ms -1. Okay. So, kalau kita cakapkan along the way ni kan, we have our V kan. So, this one sengit juga. So, maksudnya you punya V ada nilai Vx dengan Vy. So, this one, the V also sengit. So, maksudnya you have to find the value of Vx and Vy first. Okay. So, kalau semua along the way ni, we denote as V. Okay. So, this one 40. Mestilah dia punya initial velocity lah. Okay. So, at this point, this is our U. Okay. But, waktu ni, dia bergerak, plane tu bergerak macam ni tau. Okay. It moves like that. Okay. Dia hanya bergerak di X component sahaja. Okay. Waktu ni sampai at this point. Okay. Because we are talking about initial velocity Lepas tu barulah package tu drop kan. Barulah ada velocity yang velocity dia lah. Okay. Tapi waktu awal-awal ni saja dia bergerak di X component saja. Jadi sebenarnya 40 ms/1 ni adalah nilai Ux. Okay. Jadi kalau dia bergerak di X component saja, so dia tak bergerak di Y component kan. Macam mana kita tahu dia tak bergerak di Y component? Sebab your plane doesn't move like this. Okay. It move straight macam tu saja di X component. Jadi waktu ni kita boleh cakap nilai Uy sama dengan kosong lah. Okay. So at this point, okay, bila package tu dah jatuh je macam ni, bila dia dah sengit je macam ni, maksudnya kamu ada nilai Vx kamu, ada nilai Vy kamu. Dekat sini lain nilai dia, kat sini lain nilai dia, kat sini lain nilai dia lah. Okay. So kita cuba buat apa yang dia nak kat sini. Dia nak time. Okay. Okay. Oh, we have the value of 100 also kan. 100 ni apa? Okay. So, this is our release point. Okay, kosong. Okay. So, ini adalah displacement kan. Displacement mesti kita label as S lah. Okay. Tapi kita nampak clearly is in Y component. So, ini adalah SY. Okay. Okay. Disebabkan dia di bawah our release point. Okay. Kalau kita buat graph kan. Okay. So, bahagian ni adalah negative Y kan. Jadi, kita akan cakap negative 100 lah. Okay. So, don't forget to put the negative. Okay. Kalau tak, kamu punya calculation would be incorrect lah. Okay. So, if we could just write down what we have here, information of X and Y component. So, we have that Uy is equals to 0. And then we have, terbalik. So, Uy is 0 and then our Ux is 40 ms -1. And then we also have our Sy is negative 100. I think that's all yang kita ada kan. Okay, so we want to find the time. Okay, time. So, tengok formula apa yang kita boleh guna. Kan? Kalau dekat X component, we could use this formula. Okay, because you got time. Okay, kalau formula dekat Y component, kita boleh guna either this one or this one lah. Okay, so disebabkan kita tiada nilai Sx, so I think we cannot use this formula lah. So cannot. Okay, so let's say lah if I want to use this formula, okay, ada sudah nilai Uy, tapi kita tak tahu nilai Vy berapa, iaitu nilai daripada sini. This is our Uy kan, so Vy mesti point ni lah. But we don't know the value of Vy over here kan, because we want, kenapa point ni dengan point ni, sebab time tu adalah from here to here lah. Okay, so but we don't have the Vy over there, so we cannot use this one. So how about this formula? I think we can use that one lah, sebab kita ada Sy ada, Uy ada, and then we want to find the time. Okay, so let's try to do it. Okay, so Sy is equals to Uyt minus 1 over 2 gt square lah. Okay, lepas tu kita masukkan information yang kita ada, iaitu negative 100, this one would be 0, negative 1 over 2, g is 9.81 t square. Okay, so kalau kamu selesaikan kat sini, press your calculator, you should get your time to be 4.51 second lah. Okay, jadi masa yang diambil untuk daripada sini ke sini adalah 4.51 second. Okay, let's try to do the B1. Okay, B, it wants the Sx. Okay, so Sx, it means that satu saja formula kan pasal Sx, iaitu Sx is equals to Uxt. So I'm going to write down the formula. Sx equals to Uxt, and then we have the value of Ux, which is 40. And then how about the time? Okay, so time I could use 4.51. Kenapa Miss boleh guna 4.51? Because so the time from here is to here is 4.51. And you want the distance from here until here lah, which is relatively the same lah. So this one from here to here, tanpa ending dengan beginning dengan ending dia sama. So ni pun sama, beginning dengan ending dia pun sama lah. Okay, so I could use the same time lah. Okay, so for kalau kamu tekan calculator, 4.51 times 40, I think you get the answer to be 181 meter. Okay. Okay, so for C, we want the velocity over here, but we have to find the value of Vx and Vy first lah. Okay, so in projectile motion, okay, so kita dapati, okay, nilai velocity daripada derivation formula yang kita buat tadi, kita dapati bahawa final velocity akan sama dengan initial velocity. Okay, sama juga kat bawah ni, final velocity sama dengan initial velocity. Okay, this concludes that velocity, tak kisahlah dekat mana-mana kat X component, could be here kan, could be here kan. So the value will always equals to the Ux. So dalam kes ni Ux kita adalah 40. Okay, jadi kita boleh cakap nilai Vx sentiasa 40, dalam situasi ni lah 40, and this one is 40. Jadi untuk menjawab soalan C ni, before we find the value of our V, okay, we have to find the value of Vx, iaitu Vx kita adalah 40. Okay, jadi kita pun tulislah our Vx is 40 ms negative 1. Okay, and then we have to find the value of our Vy. Okay, so Vy, you have to take a look at the y equation formula. So these two equation got Vy. Okay, you could use either one. This one boleh, this one pun boleh, but I'm going to use this one. Okay, so Vy is equals to Uy minus gt. So I already know that Uy is 0, so it will be negative. G is 9.81. Again, the time from here to the final velocity, okay, masa yang diambil daripada sini sampai sini adalah 4.51 tadi. So I can use the time here to find the velocity here lah. Okay, because masa time 4.51 ni di sinilah, di sini 4.55 punya time. Okay, this one time dia kosong lah. So this one, that's why I can use the Vy over here lah. Okay, the time to find the Vy. Okay, so I hope you understand that. Okay, so this one is 4.51. Okay, so I cannot use 4.51 dekat point dekat sini lah to find the Vy over here, because I don't know the time from here to here. Okay, so Miss tahu sudah time daripada sini ke sini adalah 4.51. That's why I can use that formula lah. So if you press your calculator, so I think you get your answer to be negative 44.24 ms negative 1. Okay, so make sense the value is negative because our vector Vy is ke bawah lah. Okay, ke bawah, so negative sign lah, that's why you obtain negative answer over here. So in order to find the value of V, so you have to use hypotenuse over here, iaitu V equal Vx square plus Vy square root answer. Okay, and then masukkan saja nilai tadi. Okay, and then you get your answer to be 59.64 ms negative 1. Okay, so that is for C. So the dA1 is the angle of the impact, which is this angle over here. So if I were to zoom in kan, okay, or I were to draw, okay, if I were to draw for D, this for example for D, let's say you have your V over here, okay, and then I know that the Vx is over there and then the Vy is here. So I have to find the angle kan. So Vx is 40 ms negative 1 and then the Vy is negative 44.24 lah. Okay, so in order to find the angle, I am going to use the tangent theta. Okay, so remember tangent theta is TOA. TOA means tangent theta is opposite over adjacent. Okay, so in our case, okay, this is our opposite. So our opposite is Vy, okay, and then our adjacent is here. So our adjacent is our Vx lah. So make sure you put modulus so that our angle is always positive. Okay, so negative 44.24 divided by, okay, because opposite over adjacent kan, opposite our adjacent, jadi opposite kita adalah nilai Vy lah, iaitu negative 44.24 bagi dengan our adjacent iaitu nilai 40. Okay, so you press your calculator, so I think you get your answer to be 47.88. Okay, thank you.